That's what we're going to talk about right now.
All right.
So, the function, the number 11 they gave you, that's like an f. And then remember that I simplify it to x, 1 over x plus 9. That's like a g function. So, these two functions can be same except which one? Only one point, which our problem is what? X equal to 9 is only different. Every place else is what? Same. So looking at the picture, looking at this problem, I cannot plug in 1. Why not? If I plug in 1, you get 1 minus 1, get what? 0. It's your problem. 1 to the third minus 1 gives me 0. It's your problem. I cannot do this problem. So when you simplify this, this is 1, then you can do 2 different ways. If you already know how to factor, you can just factor. If you don't know how to factor, in that case you have to do long division. Long division, like if you have a memorized, things like that, it's a very, very common factoring. So you can memorize it for whatever reason you have not memorized, you can always do a long division. But anyway, when you do this problem, it can be factored like this. It can be factored as x minus 1 times x squared plus x plus 1. This is how you factor this. When you factor this, you get this. Okay? Don't worry about this part right now. That's not the important part. The important part is not a factor. The important part is you understanding how am I going to eliminate, make this into something that I know how to do. Are you with me? So, right now I cannot find the limit because I get 0 over 0. It's a problem. So what can I do? I need to simplify this by factoring or doing a long division. So x to the third minus 1, when you factor that, that's equal to x minus 1 times x squared plus x plus 1. You can memorize this actually, okay? This is a very common one we use. And then that over what? X minus 1. So x minus and x minus 1 can cancel out. So what are you left with? X squared plus x plus 1. So this is equivalent to this, the given function, except one place. Where? X equal to 1. That's the only place it's different. So when you look at the picture, that's what the picture looks like. This is original function, f. This is a reduced function, g. Look at it. Function f and function g. They're exactly the same, isn't it? Except which point? X equal to where? 1. This one has continuous function, which is what? Every place is filled. This is continuous everywhere except which number? X equal to 1.
That's what the little hole is.
Right, so that's why I can reduce this function into what? Simpler function by doing a factoring. And then I said, then I can find the limit. Limit is 3. I know this is limit is 3 because you look at the left-hand side, approach to 3. Look at the right-hand side, approach to where? 3. Yes, I have a limit. I don't have a y value, but I have a what? Limit. This class, do you see the difference between this function and the function? This function has a y value at x equal to 1. No. This does not have a y value at x equal to 1. Is everybody with me? And this one is what? It has y value at x equal to 1. Is everybody with me? So this is a continuous everywhere. This is a continuous everywhere except x equal to 1. So I will talk about this in lesson 4. This kind of function is called removable discontinuous function. It's discontinuous, but if I apply one point, I can make it to be what? Continuous function.
No.
It's time to go. It's not okay.
No.
So is everybody with me now? Okay, that's what number 10, number 11 problem is.
Okay, I got you.
Okay, I'm going to go over one more thing here. Right here. So this is one. This is one something you can do right away. Can I find the limit for this? This is another example. Can I find the limit for this? First thing first, we gotta plug it in first, right? If I plug it in, negative 3 plus 3, 0. That is not good. So negative 3 squared plus negative 3 minus 6, what do you get? 9 minus 3 minus 6, which is what? 0.
Zero.
That's not good. So that means I have to do something. Are you with me? I get 0 over 0.
Yes.
So you're gonna say, okay, x plus 3 is already simplest form. But this is not a simplest one, right? I can factor that. So I'm gonna say, no, let's factor this. So I'm gonna say, okay, I can do what? X and x. What number you wanna use? 2 and 3?
Yes.
Which one is gonna be positive? 2 or 3?
3.
3 is a positive, that has to be negative here, right? So I have x minus 2 and then what? X plus 3. So let's rewrite it then. So I can finish up here then. So rewrite their problem as x minus 2 and then what? X plus 3, everything over x plus 3. So you're gonna say, okay, I'll cancel that out. Then I know what to do, right? That just equal to simply, what's that equal to? -5, right? But you have to say which one. You have to tell them. I cannot use which number here. -3 in this case, right? Because, yeah. But you did find your limit though, -5. Is everybody with me?
Yes.
So this is your f function, this is your reduced function, which is what? G function. So when you reduce this becomes a just simple line. That's interesting. You see that? It becomes a simple line. Is everybody following me? Okay. So this is like when you know your algebra, it's not that hard. Because limit part is not hard. Are you with me? The simple concept, the concept is all same. Does it have a limit means what? You look at the left hand side, you look at the right hand side, they meet. That has a limit. If they don't meet, what that means? If it's like this, you're gonna say what? It doesn't have a limit. Also, it's what? Discontinuous. All right. We just did all that. Yeah, that's the function. So this function is reduced to what? That, which is what? Simply x minus 2. So I can just simply graph x minus 2 and then make sure that -3, -5 has what? Circle. Because we don't have their value. We have a limit, which is approach -5, not the y value. Is everybody with me? Okay. So everybody knows the difference now between y value and a limit, right? Sometimes they're saying when it's continuous function. But if it's not a continuous, the limit is not same as what? Y value. Yes.
Before we go, could you help us on one more? Could you help us on one more?
Yeah. So rationalizing technique, I may not do it because I don't get any homework problem for that. So I'm done with the lesson 3.